Okay, I guess we are live. Yes, we are. Hopefully the video should be coming out fine. And what we're gonna do is we're gonna do lead coding. Now I'm gonna try to hold up and do this every single day for the next few days until I feel I'm confident back again on all of this. But until then, I'm gonna stick to doing live streaming, coding, and just try to get better at this and remind myself how it used to be. Now, keeping all that in mind, the first thing we want to know is what questions am I going to do. So I'll be trying the Blind75 list to start with, because that's just a good list to begin with when you have no knowledge of what kind of questions you might get in an interview or any particular place where you want to try them out. So generally I feel it's a good idea to go ahead with Blind75. Now, Neat Code is a website that I recently came across and seems to be pretty good. It kind of takes care of like starting, kind of putting a status, and it can sort of act like a place which kind of contains a database for you, right, of how you've been solving these problems. So I decided to go ahead with this. Plus it had all the Blind75 questions listed. So I'm using it as an index more than anything right now. And one thing I particularly don't like is something like difficulty level, right? So what I did was, quickly before we jumped on to making this live stream, I created a new extension. I'm not really familiar with JavaScript, but ChatGPT can help do a lot of things today. So I just quickly created an extension which can hide neat code difficulty. We're going to enable it. By the way, this is, so if we open this, this should be visible on my repository, right? I added it as the top. So if in case you want to have a look at it, go ahead. But as soon as we have enabled it, if we refresh, it might show difficulty for the first few seconds and then it's gone, right? So now I'm not going to be biased when I'm solving a particular question. And just for the sake of it, because I kind of saw that initial few questions seem to be easy, let's just shuffle it by problem. And now it's all sorted alphabetically and I have no clue which one's an easy, which one's a medium, which one's a hard question. So without further ado, let's begin. I do want to point out that I'm doing this as an experiment and I haven't studied these questions in a long time, or prepared for an interview or tried to do these coding questions. So what's going to happen right now is, throughout this few day series, I'm going to struggle quite a bit, as you might notice, but then it's also going to hopefully serve as a way to show how one keeps on improving and I can keep on improving, right? So it's possible that I might keep referring to documentation and learn through things, and some of the questions I'm not able to solve even after spending like 30-40 minutes on them. But the idea is that by the time I'm kind of closing up on 75 questions, that I get closer to a 20-25 minute mark for a medium level question. And if that happens, I'll consider this exercise to be successful. And if it helps out anybody else, then why not? All right, guys, let's get on to this now. So the first problem seems to be threesome. Let's open that up. And it's lead code. Okay, let's go through the question now. Oh, by the way, I have a lead code extension as well. I think that's this lead code enhancer. It's hidden for me the company. I do have a lead code premium account, but it has hidden for me the company where this might have been asked, as well as the difficulty level. I have I haven't started this before, or I have maybe. Yes, I have started before. So which means like at some point I found it to be a good question, but it's been a while. Now let's switch to Python 3, which is my language of choice. Let's go through the question. So at this point, we'll also start a timer just to given an integer, add in nums, return all the triplets num I, j, k, such that I is not equal to j, I is not equal to k, and j is not equal to k. So all the three indices are different. such that all of them equals to 0. Okay, notice that the solution set must not contain duplicate triplets. All right, okay. Okay, return all such triplets. Okay. And we gotta return the actual, not just the indices, but instead the values of the array. All right, what could we do here? Let's start with the comment section. So let's take an example. So let's say this was the example. Before going to what's happening in the output and the explanation, since that's not going to be given to us, let me focus here. Now what would I tend to do here? It's gonna be I, J, and K, right? Okay, let's go with something basic. Let's say I start I here and J here, and would it help? That might not help. What if I sort them out though? If I sort them out, if I sort them, then indices would change, right? But indices are not required, right? Indices are not required, so I guess sorting would not create any problems. What's required are the numbers. Okay, and 3 numbers should be equal to 0. So basically we are looking for num of I plus num of J is equal to minus num of K, right? So one solution that I have is that I could create a set, or a set basically gives us O1 of random access filled with all the numbers, but the challenge is that it can cause the indices, like they can be duplicate elements, like -1 is duplicate here in both the times. So but what I was going for was that then I would have just gone through, if I've sorted the numbers, I could have placed I at 0. I can't. Very interesting. The problem is actually about detecting or finding this third number in the array, right? And these two, when these two are summed up, but then I and J can be anything. Now I know that sorting would take and log in, but I kind of don't want to go into n square, because if it was n square it would be a very simple problem. So then in that case I want to think about how would I how do I iterate through all possible I and J? Or instead of all of this, if I think of it from a different perspective, what I need to do here is I pick up an element I, element number 5, and let's say we start from 0, the index, right? Then I'm left with the problem of finding see, n square solution is very simple. How do I get to n log n or lesser? If I choose -1, how would I do this on myself? If I choose -1, either I choose -1 or I don't choose -1. If I choose -1, then the problem now turns into a 2-sum problem. But the 2-sum should not be 0, it should be +1. 2-sum is +1. Okay, now for the 2-sum problem, how does it go? For the 2-sum problem, what I need to do is, let's say I choose another number 0, or I don't choose 0. Now at this point it turns into a 1-sum problem, and what we are left with is a single element, which would have to be +1. Okay, and now we have to check if this exists in remaining array. Now is checking like this. How do we check it in a fast access order? If we go from index I equal to 0 and then slowly proceed forward, would that help? Because that will, let's say this was the choice of choosing 0th element or not choosing it, and then, by the way, is this going fine? Why can't I? Yeah, it seems to be going fine. Okay, all right, so if I chose the element -1 as my ith element, or I don't choose it. If I don't choose it, my point is that I go to I equal to 1, or I start with, yeah, so if I choose it, it's gonna be like see it more to be like something like, 3-sum gets called, we want result to be 0, and n choices left are 3 at this point, and starting index is 0 at the starting. Right, now this gets called. What this should call further is 3-sum. Either we choose -1, in which case what we do is 3-sum. Now result should be, instead of 0, it needs to be minus of num of 0, or num of I basically, and n choices would become 2, and starting index would become I plus 1. And what's going to happen is, if ultimately what should it return? It's supposed to return seems odd. It'll become a 3D or 4D grid, which would be again too much more than n square than that we could have done. Very interesting, man. How did we solve this? Some magic is going on. Let's think a little more. It's 11 minutes past. We'll think until like 18th minute. So there are, what about binary search, right? Binary search can find an element in O of log n. How do we do 2 sum? If we solve 2 sum, and 3 sum is just an extension. So 2 sum, let's see, which means find 2 elements equal to 0. What you want to do is find an element and it's negative, basically. How do we usually do this? Or when it could be 2 sum equal to something else also. How would you do this? One way is store it in a set. No, the worst case for this would end up being n square again. If everything is a 0, then it can cause a problem. What's the other way around for 2 sum? So if you want to reduce the worst case to not be of n square, you maybe you want to sort it and then start from opposite ends. Would that work? So if I starts on 0 and j starts on n minus 1, then we know that, yeah, let's see. Let's say this was the array. Let's try to do 2 sum here. For that we need to sort it. So -1, -1, 0, 1, 2. Oops. Starts from -4. So this is how it will look like. Now what we are saying is, if we start I here and j here, then num of I plus num of j, if it's less than 0, which it is right now, then we know that we have to increment. We could either, if it's negative, all that means is the left side of the all that means is I needs to increment, because decrementing j was not gonna solve it, right? It's gonna make it further negative. If it's greater than 0, however, or greater than equal greater than 0, then we're gonna do j minus minus. And if they end up equal to 0, then we have found it. Right, okay. Now instead of 0, it will change to the k, right? So that's all we need to do. But the challenge is that in this case we have sorted the array, so we did an n log n here, and then we are doing an O of n parse. We can do sorting just once, but we're doing an O of n parse for each element, which could be num of k, which would make it n square again, which I don't want it to be. So so what do we do? Okay, it's 19 minutes. Not able to get beyond this, so the max I was able to think was of n square sort of solution. But this 10 to the power 5 basically means that we need an n log n. Now, that means that at this point we'll have to see the solution. Sorry guys, not off to the greatest start here. I guess this is how it's gonna be anyway. Okay, let's go through the solution. Python 3. Actually, over here. Follow-up of 2sum, fair enough. Good idea to take a first look at 2sum and 2sum 2. Okay, interview may ask to solve 2sum. Okay, 2sum, 2sum, 2 and 3sum share a similarity. That's sum of elements but okay, difference is that instead of exactly one answer, we need to find all unique triplets. Fair enough. Let's check the existing solutions. Determine best conceivable runtime for 3sum. 2sum uses a hash map to find complement values. This was sure I can do that too, right? I talked about hash map. 2sum 2 uses a 2-pointer pattern, also has a 1 time complexity for a sorted array. You can use this approach for an array with sorted first, which bumps. Exactly what I thought about, right? Considering that there's one more dimension, it sounds reasonable to shoot for. Are you serious? Are you serious? Really? Please tell me that that's not the what the dude, I can do this for O of n square. If O of n square is the solution, then there's no point, right? I can solve it in few minutes. So let's take like what do we want to do for O of n square? It's very simple. So you pick up k. You start with a for loop for k, and then all you need to do is you need to find num of I plus num of j, which should be, if it like at this point we can sort the array first, right? So first what we'll do is num sort, right? And once you've sorted the array, what we want to do is for k in range 0 to len of nums. Now k is set, right? So what we want is nums of I plus nums of j should be equal to minus nums of k, right? And this is what we want to return if I not equal to j not equal to k, right? Okay, fine, fair enough. So then we'll do for I. Now this is the first loop, right? This will do O of n on its own. Now what we want to do is we'll start I at 0 and j at len of nums minus 1, right? And then we'll just start doing this O of n pass, which would mean that while let's say while true for starting, right? What we'll do is, and we can store the result in an array, and we're going to return that result at the end. What we want to do at this point is go ahead with checking if nums of I. First of all, we want to make sure that if I is equal to k, or j is equal to k, or I is equal to j, then what do we do at this point? Interesting. We need to change one of the values. Okay, so let's break this down. If I is equal to k, then we need to do I plus equal to 1 to if j is equal to k, then we need to do j minus equal to 1, and this should be while I not equal to j, right? If I becomes equal to j, then the while loop will end. Fair enough. Okay, now in this case what we would do is we're gonna check and let's just push continue here, why not? Now let's say we have 3 different integers. What we want to check is if nums of I plus nums of j is less than wanted equal to minus k, actually, right? If it's less than minus k, then the left side needs to move forward. So I plus equals to 1. If nums of I plus nums of j is greater than equal to minus k, then j minus equal to 1. And else they are equal, which means that we can add result.append. It should be I comma j comma k, and in this case we can do I plus equals to 1 and j minus equals to 1. Yeah, right. And essentially this should kind of work. This should be nums of k. And these are numbers, so it's nums of I, nums of j, nums of k. And then we can just I think we are already running result. So see, I think we wrote the code within 5 minutes. Now the challenge is to kind of dry run it. Thankfully we've been given a test case, so let's try to do dry run. Right, okay, so what will happen is let's say our k would be this, I would be this, and line number 55, and j would get chosen. Oops, first of all we're gonna have to sort this array. So let's say we sort it, it becomes -4, -1, -1, 0, 1, 2, right? And now k is here, and then I is here, and j is here. Actually I is here to start with. Now k is gonna go from this index to 2, right? We start with I equal to 0, so I set here, j is length of nums 1, so j is set here, and then we go into while loop. If I is not equal to j, I is not equal to j at this point, so we can go inside is I equal to k, which is true. So let's just push I plus equal to 1 and continue. Is I not equal to j still? Yes, that's correct. Is I equal to k? No, it's not. Is j equal to k? No, it's not. If nums plus I plus nums of j is less than equal to nums of k. So let's summarize here. Nums of k at this point is -4, which means minus nums of k is 4, right? So we want to see if this is 4, and nums of I in this case is -1, and nums of j is 2. -1 plus 2 is +1, which is less than 4. That's true. So we're going to increment I. So I goes in here, and that no else blocks will run while we go inside. I is not equal to j still. Yes, that's true. It's again -1 and 2. I is not equal to k at this point. J is not equal to k. It'll go here again, because the answer would be +1 again, which is less than 4. So I will be +1 again. I will go here. It'll become 2. It'll go here. Won't work. Or won't go inside of those blocks. Now this would end up being 2. 2 is still less than 4. So I is gonna be incremented further. I'll become this number, and this is 1 at this point. I is not equal to j at still. I is k, no. J is k, no. Total is 3 at this point, which is still less. So I is gonna get incremented to be +1, and at this point I becomes, actually this should be I is not equal, instead of I is not equal to j, it can be I is less than j. Yes. Oops. Now at this point I has become equal to j. So I is not less than j anymore. So at this point we will exit this loop, and nothing will happen for this k. And what we're going to do is move k forward. Let's move k forward. Hopefully this will give me a solution. I at this point is equal to k. No. So this won't work. J is not equal to k. what's happening with nums I and nums j. By the way, nums minus nums k at this point, let's directly write that, would be +1. And I plus j is -4 plus 2, which is -2. -2 is actually less than +1. So I is going to move forward. Now at this point, I is less than j. Sure, but I is equal to k. So I is going to move forward. At this point, -1 plus 2, which is going to be +1 actually. And at this point, this will become the case. The result will append -1, -1, and 2. So we'll finally have result as -1, -1, and 2. And how many? So that was the actual first result. Let's keep going. Okay, I'm kind of tired now at this point, but just speaking, I guess I should drink some water. All right, so what should we do next? Yeah, so this one has kind of worked for us. I will increment further 1 by 1, and j would decrement by 1. Do we want to do this, or do we want to just increment 1 and keep the other at its own place? What will happen if j stays here? Are we missing out on this case? Yeah, we technically are, right? Because let's say if this was -1 as well. Now, I would not want j to be done to the previous index, because then I would miss out on this -1 and 2 and this -1. So that's kind of interesting as to what we should do in this sort of a case. Whether we go forward with I or j. What if I only increment one of them? What if I only increment I always? Would that cause any issues? No, actually. So I can just increment I, right? In which case only one of them moves forward. I will always get 0 and 2 case. If I had instead, let's say, moved j backward, I would have gotten -1 and 1 case. Which would I not get it now if I moved I forward and j stays there? Yeah, I would not get that. This is very, very interesting. Interesting, man. Very interesting. If at this point I end up doing, if I end up doing both a check for I plus 1 with j and I and j minus 1, that kind of becomes recursive, which we really don't want to do. This is very interesting. I'm sure this won't work. So, yeah, it's not gonna work, but oops. Yeah, wrong answer. Wow. So many exams. I think what I'm missing out on is that there will be some, like, obviously my solution is spitting duplicates. The reason being I'm going through k again, and there'll be another case where I and j takes different values and k takes another value of the same set. So it forms all the permutations of I, j, and k right now, which we don't really need. So like one way to get around that issue is just store a set of I, j, k tuples, and if we encounter the same tuple again, then we could potentially say that, something's wrong with this one. But anyway, I'm really tired. Let's see the solution, and I think I might sleep off after this. But I will return tomorrow, and I'll try to solve about, like, I'm not gonna commit at this point, but I will try my best to sit here and solve as many problems as I can. Let's see. We'll go through this solution, understand it, get the aha moment, and then wrap it up. Sorting would not change the overall time. Need to skip duplicate values. This is something I missed. Easy to do because repeating values are next to each other in a sorted array. We may move our and analyze elements to its light, right, which is what we try to do. Initially set to first and last element respectively. I've never thought about, like, when k is moving, I needs to go always from like k plus 1. Would this just give me, like, it does make the output better for sure. Right, this is the point of incrementing to avoid duplicates. Hey man, it's gonna fail. Don't go. No, come on. Yes. Actually, basically it's I plus equal to 1, j minus equal to 1. And now this is while loop. Still didn't work, man. What up? Oh, this stuff is not required anymore. What? What the fuck is going wrong? These two things have been set up correctly. Instead of I have k. Okay, that's fine. Now if this does a nifty trick, which is fine. If I don't do it, that's also gonna be fine. It's not gonna find anything, that's all. Let's see at this, right? So if I equal to 0, the only difference I see is an if condition here. So if I is equal to, sorry, if k is equal to 0 or nums of k minus 1 not equal to nums of k, and if I add this in here, it should somehow work. Very interesting. So what's the magic in this line, man? What it's saying is, if in case k is 0, if it's the first index, then we surely want to go inside regardless. Otherwise, we also only want to go inside if nums of k minus 1, which is a previous element, is not equal to the same k. Because if it is, then we're gonna get the same triplets. Okay, so this is to avoid duplicates, and we're gonna do it from 0th index, because at 0 we can't have k minus 1. So this is very cool. I guess it's gonna work. Yeah. Alright. See, last time I tried it was like 2020. So it's gonna be more than 2.5 years. What did I do at that point? So I created a set, which is cool, but not so cool also, because every time it would be checking for duplicates. And range, current target, J, K. Well, technically, this, just because of the set, it kind of worked, but it wouldn't have been as yeah, 28.6%, and right now it beats more, right? It does take more memory. Somehow set fixes that.